Welcome to this latest wildfire edition of my weather and climate office hours. This is an hour that will be different than I had anticipated it being just yesterday when I initially scheduled it 24 hours in advance, because at least two major things have happened since then, up in Canada and then again in Northern California. So I'm going to discuss recent events and the broader context. But before I do that, just some brief introductory matter at the beginning. Wanted to highlight once again that REASC, a company rethinking Earth system risk, is a partial sponsor of this Weather West channel. And also wanted to remind folks that you can really help out quite a bit by subscribing to the channel, liking videos, and also, if you are able, by contributing via the links that I put up in the comment section to start out today. So feel free to check those out if you're so inclined. And thanks for joining. So the wildfire situation in the western US and also notably in western Canada. So this is really a western North America problem right now, not just an American or a Canadian issue, has really escalated in recent days, quite dramatically. In fact, just in the past 48 hours. So conditions have become dicier and dicier over the past few weeks, as much of the western half of North America, the continent, has experienced record-breaking heat. And that's certainly been true in much of California and the interior Southwest, but in recent days that has also extended up into the Pacific Northwest, the Great Basin, the Northern Rockies, and the Canadian Rockies in the interior of Western Canada, with all of these places seeing very long duration heat waves. In some cases, places experience their all-time hottest days on record, but in far more places, new records were set for either cumulative or consecutive number of days above very high temperature thresholds, whether that's 90 degrees in cooler places or 110 degrees or 115 degrees in desert locations. We've just been breaking records left and right, and also across a very broad area, all the way from northwestern Mexico to western Canada. So this truly is a situation where most of western North America is in it together. And not only that have we seen record-breaking heat wave for weeks on end in some places, we've also seen a tremendous amount of lightning. The summer is thunderstorm season in most of the West, except for coastal California, where thunderstorms are rare at any time of year. But we've seen a lot of lightning activity, including a fair bit of dry or a mix of wet and dry thunderstorms. And this is really not a good combination when you have a period of antecedent record-breaking heat for weeks on end that has dried out vegetation, in some cases to near or above record dryness levels. So you have all of this lightning come along, and of course that has a much higher likelihood than usual to ignite fires. So the conditional likelihood of a wildfire ignition given a lightning strike is higher than it would usually be. And then also, if you do have those ignitions, the degree to which those fires are likely to take off quickly and become dangerous also increases as you increase the antecedent dryness. And now more recently, what we've seen are some summertime winds. The winds themselves have not been particularly extraordinary, but they come at a particularly bad time, because now they're pushing these fires that have been ignited by lightning in most cases, although not all, in the context of a multi-week period of record-breaking heat. So there's a lot going on, there's a lot to discuss, and I'll get to all of this in just a moment. So I think the two major things that have happened in the past 24 hours are that a cluster of wildfires in Western Canada, particularly one that was burning in Jasper National Park in the Canadian Rockies and near the town of Jasper itself, was pushed by very strong winds following record-breaking heat directly into the town itself overnight last night. And the town had been mostly evacuated the day prior, but there were some stragglers and a lot of emergency responders who were in town when this wind shift occurred and essentially caused a crowning forest fire to rapidly advance on the town itself. And unfortunately, it sounds like the reports are still a little sketchy, but it sounds like there has been yet another Canadian town largely destroyed by wildfire. So Jasper, a town of, for the region, a substantial population center of around 5,000 permanent residents and tens of thousands of visitors who come in the summer, it sounds like much of the town was in fact destroyed by this fire, which blew in when strong winds ahead of a cold front that did end up dropping some rain after the fact. But of course, the winds preceding the cold front occurred before the rain, and unfortunately, the fire front made it to town before the rain did. So it sounds like another major wildland urban interface fire catastrophe up in Canada, in Jasper, in the town of Jasper. The scope of it is unclear, but it does sound like half or more of the town was probably destroyed. I was up there some years ago, and I was there with a person who also studies wildfire, and one of the things we just kept remarking on is it's a region of great natural beauty, much as a lot of California is too, but one of the things we just couldn't get over was the degree of obvious fire risk, the very closely spaced conifers, the obvious lack of recent fire history, the number of dead and down trees from bark beetle infestations, which are increasing in a warming world, and the fact that there really weren't very many egress routes or margins in the vegetation along those egress routes, and all of that played into what transpired overnight last night. The only good news is that it does sound like everybody made it out because there was a day of warning. It wasn't necessarily going to be the case, so that is good news, but it does sound like this has been a devastating fire for the town of Jasper, and this fire continues despite the rain. It wasn't a lot of rain, and fire conditions are expected to ramp back up with more heat and windy conditions in the coming days. So probably have not heard the last of that, and that'll be a developing story up in Canada. But really, this is just the northern arc of an incredible wave of wildfire activity extending all the way from Southern California up through Western Canada. As I mentioned, California, until very recently, was not really at the epicenter of this. The worst fire activity was actually up in the Pacific Northwest, so eastern Washington, Oregon, interior British Columbia, western Alberta, as well as the Northwest Territories and portions of Saskatchewan. But now, just yesterday, in fact, almost exactly 24 hours ago, a fire initially ignited in, I believe it was Bidwell Park, just outside of Chico, so just a little bit up the slope, up in the hills east of town. And this is known as the Park Fire, I believe, for that reason. This is a fire. This is really the first fire in the past several years in California where I would call its behavior extraordinary, and that's not a good thing. So far this year, we've seen some big fires. We've even seen some fires that have destroyed some homes and caused some problems, but generally nothing catastrophic, nothing that really was outside of the range of recent experience. Granted, the 2010s were a decade of incredible occurrences from a California wildfire perspective, but so far this year, we hadn't seen anything that looked quite like that. I think we are now, with this new fire burning up in northeastern California on the western slope of the northern Sierra foothills, or the northeastern foothills flanking the Sacramento Valley, between Chico and Redding. This fire is a big deal, and it has done some pretty incredible things over the past 24 hours, as I will show you in a few minutes. This is a fire that advanced in the initial hours at about 2 to 3 miles per hour. So this is a fire that essentially advanced continuously at or above walking speed without slowing down at all in the overnight hours. Accordingly, it's been burning for about 24 hours. It's been advancing at about 2 miles per hour. This is a fire that has now burned on an almost 40 to 50 mile fire line since yesterday, 24 hours. Most recent estimate, this fire was about, officially, 75,000 acres, again, from 0 to 75,000 in less than 24 hours. But at this point, I suspect it's actually quite a bit larger than that, and would not be surprised if this is already a 100,000 acre plus fire, and it is still growing rapidly on 3 out of 4 flanks. This is a fire that has caused some structure loss. There's some very rural communities, Cohasset in particular, the southern portion, where there was, and the details are still emerging, I don't know the details, but where there was a pretty frenzied evacuation last night because there are very few routes of egress in this region. Some of these are dirt roads. A lot of them are private gravel or dirt roads owned by forestry companies, timber companies, with locked gates. And so the timber companies did apparently open those gates, but there was a period of time, I don't know if it actually occurred, but where the plan from the state of California was to evacuate people via National Guard Chinook helicopters, which were dispatched, and the instructions over the radio were for people to go to the helipad. I don't actually know what has transpired because news has been pretty slow to get out of the region. It is a quite rural area. It's possible that telecommunications are limited. The cell phone coverage is already pretty weak in that part of California, but right now the fire is likely disrupting it further. There was some structural loss, as I mentioned. This did burn through not really neighborhoods, but dispersed homes in the canyons there, which makes it in many cases more dangerous because these houses are nestled in the vegetation. It's true WUI, wildland-urban interface type setting. These are not large communities, but there are still a fair number of people who cumulatively live in somewhat distributed fashion up there. The only good news right now with this fire is that it has largely burned through what populated area in that canyon it's likely to in the immediate future, although Cohasset itself is still at risk to the extent that it hasn't yet burned. It's now continuing further north and east into an even more remote part of California, and quite frankly, the only good news is that there are no large communities in the immediate path, because all the other news is pretty bad, which is to say this fire is behaving incredibly aggressively. It's exhibiting extreme and exotic fire behavior, very rapid rates of spread among moderate winds, but record dry vegetation conditions following this record heat wave that we've experienced in this part of the state that's lasted for weeks. Also following a relatively wet winter, so a lot of what's burning at lower elevations is grass. At the middle elevations, it's a mix of grass and brush, and the upper elevations of the fire are now moving into timber, I believe, including some timber plantations. So those monoculture plantations that folks like Zeke Lunder, if you follow his work, will tell you burn like hell and a lot more aggressively than a healthy natural forest would. So, there's a lot of fuel ahead of this thing. In fact, it's actually moving into more remote areas with heavier and heavier fuel, and there is a large region. This is sort of filling in the gaps up in northeastern California in places that has not burned in recent years. So this thing is going full steam ahead. It's still moving as fast as it ever was, and the plume itself has exhibited supercell thunderstorm-like characteristics, including large-scale rotation, possible fire whorls detected on radar, and frankly, the smoke plume itself has just visually resembled like a Great Plains supercell thunderstorm, at times pretty remarkably. The camera views are pretty amazing, and I will bring some of those up to see what it looks like live in just a few minutes. This is a fire that is likely going to become several times larger than it currently is, at least, meaning that it will likely be a several 100,000 acre fire. I don't really see how that won't happen, partly because this fire made a beeline up the north-northwestward direction up the Sacramento Valley foothills, burning at the lower elevations in grass and establishing what is now a 40-mile wide active fire front. The problem is that now that 40-mile wide fire front is essentially parallel with the topography, meaning that fire, in the absence of a strong wind that's pushing it in a different direction, likes to move upslope. Now there's a 40-mile wide line that once the winds die down a little bit, this fire is actually going to start to become more terrain and fuel dominated, and it's going to start to move up these canyons more aggressively. And it's going to do so almost continuously over all the drainages over a 40-mile wide swath with very little in the way of road infrastructure or other infrastructure to stop it. There's a lot of fuel ahead of this thing. There's a 40-mile wide fire front. When the winds shift, it's going to become a 40-mile wide fire front going in the other direction. And so this thing is likely to become an enormous fire. In fact, as I'm going to show you in a moment, just the visible burn area from satellite imagery already appears to be roughly the size of Lake Tahoe. Again, this is what's burned in the last 24 hours. This started at slightly more than 24 hours ago, yesterday, near Chico. This is a fire we're going to have with us for weeks, if not months. This may be one of those fires that starts in midsummer and burns into autumn, depending on how things go. They could end up posing more of a threat to communities later on. As I mentioned, it's now moving into an even more remote and rural area, but it has the potential to become so large that it may eventually move back into more populated parts of northeastern California later on. I do think they'll probably get a handle on the southern flank near Chico pretty quickly. I'm sure it's an emphasis for firefighting right now, but frankly, on the northern and eastern flanks right now, this thing is burning so aggressively in such a remote area under such extreme conditions that there probably isn't a whole lot of active firefighting that can be done, either aerially or on the ground. It just isn't safe for firefighters, and it probably wouldn't be very effective anyway under these conditions. So I do expect we'll see containment on the western flank facing the valley, on the southern flank facing Chico, but frankly on the northern eastern flank I don't see that really happening for weeks. So this thing has a huge amount of room to grow and may even grow to reburn some areas that have burned in recent years. In the Dixie Fire, where there's been enough vegetation regrowth or deadened down timber from the fire itself, the intensity may be lower in those regions, and that may actually be where firefighters eventually get a handle on this, is within those burn patches. But there has been enough regrowth in a lot of these recent fire zones that there may be this is an example of a fire that, especially under windy conditions, given historically hot and dry conditions, could well reburn areas that have burned as recently as 2 or 3 years ago. So following 2 wet winters with good growing conditions, there is essentially contiguous grass and brush in most of these burn areas. So of course the mature forest hasn't grown back in anywhere that burned in the last few years, but there may well be a continuous fuel bed for these fires. So I'm going to start bringing up some satellite imagery just to give folks a sense of the spatial scale of what I'm talking about here, because it is genuinely remarkable. In fact, I actually kind of did a double take when I saw this just a minute ago. So let me share my screen. You're going to see the infinite window for a minute there, but then you should see shortly thereafter what I'm intending to show, which is a satellite view. I need to figure out a more efficient way to do that. But anyway, okay, I think it's pretty obvious what feature on the map I'm talking about, but I'm going to bring my drawing tool up anyway, because there's a few features I want to illustrate. What we've got here is, this is live satellite, so this is being piped from the Goes West satellite live to my computer, and then onward live to your screen, phone or computer. This has just a few minutes of latency, so this is literally just a couple minutes old, so this is essentially and functionally in real time. Obviously the fire I'm talking about is here, in this red circled region. This is the park fire. But look at this black region that I'm outlining right here. That is the clear extent of the fire that has already burned. Again, this started yesterday. And compare this to the size of Lake Tahoe. It is similar in size. And it certainly, I think, will become equivalent or larger than Lake Tahoe if it isn't already. But that is a pretty remarkable degree. I mean, you can see that dark black area. That is literally the area that's burned in the past 24 hours, so you can see it. Also notable is a new fire down, by the way, in Lake County. Not nearly as large. We'll see what happens. I'll take folks to a live camera view down there. But just again, look at this volume of smoke. This smoke plume is now crossing into Nevada and will likely cross into Oregon and places further downwind soon. This is this is a big deal. And what you can also see are right up here these occasional white puffs. Those are pyrocumulus or pyrocumulonimbus clouds. Fire thunderstorm clouds. I don't think this has produced any lightning, but it has produced strong rotation and maybe even fire vortices. This is something that may actually continue to amplify throughout the evening as the winds pick up, and there is a red flag warning now in effect. The other thing I wanted to point out is that there's not a lot of smoke coming off of this flank of the fire, the western and southern flank, as I mentioned. This is the one that's closest to populated areas, so it was probably a focus for firefighters, and it's also probably the easiest to access because this is what's mainly burning in grass and at lower elevations with more road access. But the eastern flank of the fire, the whole flank, this is what I mean about a 40-mile long active fire flank. You can see this is essentially all burning actively and aggressively. And the concern is that this is going to move inland upslope. So this progression map might look like this. And as you can see, there's a lot of densely vegetated areas here, including some overlap with recent fires, but also some areas where there's not a lot of recent overlap. This is not a prediction for how big the fire could become, but there could be progression both to the north and to the east. And so I'm guessing that there are fire folks thinking about very big boxes, as they call it, for this fire. This one has a lot of room to grow and not a lot that's likely to stop it. There is some active fire still on the northwestern flank and definitely on the northern flank too. So as I mentioned, areas within this sort of region are also potentially at risk. This thing could continue to run up the eastern flank of the Sacramento Valley if wind conditions are favorable, as well as running upslope the canyons. And I'm not a fire behavior expert, although sometimes I play one on TV. But I know Zeke Lunder does some live sessions. I haven't seen any of his for this fire yet, although I know he's done them, but he'll probably talk in detail. This is sort of his literal backyard up in Chico and Deer Creek drainage, so he's very familiar with this area, so he'll have some more specific information. But this fire has room to grow, especially upslope, which is in a direction it could go really far, but also to the north, along sort of flanking the eastern slopes of the Sacramento Valley. And again, you can kind of see just based on the color here, this region here is mainly grass, so there is, unless there's a strong wind pushing it, they'll probably be able to prevent much westward progression in grass fuels, although they are very dry. But everything to the east, as you go eastward and upslope, you get into some pretty dense forest and commercial forestry plantations, and those are super, super flammable. So that's going to be a big concern. There's still some residual smoke up here, by the way. The fire is burning up in northwestern California, but no big plumes, so those are looking better right now, at least. But let me go to a different region. I'm going to take you to central California, look at some of the fire activity there. It's nothing nearly as dramatic as further north, but there are still significant lightning fires in the southern Sierra. You can see one of them right here, burning. This was, again, ignited by lightning. As was this one. And there have been some fires in the transverse ranges, but not seeing a lot of smoke, so that activity has decreased. So there is southern Sierra fire activity that may pick up again in the coming days, although it doesn't look too bad. Right now in California, the big story is, again, and I'll go back to it just to show you for scale, is definitely the park fire. It's looking pretty bad, to be quite honest. The only good news is that as you go north and east from here, it's a while before you hit any population centers, but it is possible that this thing becomes so big that it does start to hit some of the population centers later on, not imminently, but in the days to come, up in this part of California. and there are towns up here. So that have been quite fire affected in recent years, and unfortunately this might be another one. And I'm just going to take a tour going north. Here we go into Oregon. Slightly calmer fire day today, although still you can see the extent of fires. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 major fires here alone. Oh, 12. And these are fires that are burning in the Cascades, so these are densely forested environments in a lot of cases. These are not going to be easy to extinguish. Also in forested environments here, these are going to be with us for days or weeks to come. In fact, many of these fires are going to burn probably until the rains arrive. My hope is that we don't see a September 2020 Labor Day wind event that blows all of these fires in the Cascades up and shoots them westward, as we saw during that event. We're still a ways out, but these fires may well still be burning then, as with these, so that is a concern up further north. Continuing the northward tour, you can see that there are yet more fires in the Cascades south and east of Portland, and then again in eastern Oregon, and then again fires burning in eastern Washington in different vegetation types. This one, for example, mainly in rangeland, grass and brush, although it's quite large. You can see that the black footprint there from the recent fire activity. And then here again, east of the Cascades, large fires burning mainly in forested environments in eastern Washington as well. Continuing farther north, or actually let's go east into Idaho. Right now that's mainly drift smoke, although there is some fire activity there. This is eastern Oregon, again pointing out that there are some fires in northern Idaho as well as far eastern Washington. So most of these were started by lightning, so we often talk about human-caused fires, but in fact, in many cases, these fires right now were mostly sparked naturally by lightning. And then I'm going to continue north because there's yet more to see. Here's northern Idaho and northeastern Washington. Not quite as extreme, but you can see there's another major fire here and some in northern Idaho Panhandle. And then as I go north into Canada, what you're going to see is something a bit different because here's the wider view. I'm going to bring my drawing tool back up. The Jasper fire I was talking about was essentially in this region here. Actually a little bit further north, maybe. I guess it's more like in this region here. This is the part of the Canadian Rockies where Jasper was unfortunately largely destroyed last night by fire. There's a few things you can see that's going on. First, you can see this cyclonic swirl. So you see the low pressure system here. You can see a lot of clouds, so that's the white stuff. But you can also see all this brown smoke mixing in with the clouds. So here is smoke mixed with thunderstorms. This is smoke from Jasper and the forest that burned around it. So that whole blob came from here yesterday evening and is the remnants of the town and the forest nearby. But the point I wanted to make is there's a low pressure system here. This area is seeing some showers now. As I mentioned, there's some precipitation. So these fires, if you'd looked at this map yesterday, you would have seen literally hundreds of fires burning in this entire region. This is a vast area of Canada, and this storm has temporarily attenuated many of them, but it's very likely that this hasn't really extinguished any of them. And so this is something that you'll see again in coming days. It looks like this area is likely to see below average precipitation and above average heat in the days to come, so we've not seen the end of this despite the temporary reprieve. Okay, so I'm just going to zoom out to the Watch Duty app map of the western U.S., and you can see there's just a whole lot of fire out there. Not all of these are large and threatening fires, but you can see that sort of along this axis here, and I'll just sort of draw this out, along this sort of axis right now is where the most significant fire activity is in the United States, and a lot of this was started by lightning because this is the region where there's been major lightning activity in recent days. Oh, that's why I can't use that. I need to update my subscription. Anyway, so there's a lot of fire activity going on. But what I wanted to do here was actually zoom in on a couple different things, take a few views. So here is the park fire. As you can see, lots of evacuations, red flag warning in effect. I think this fire footprint is old. It's likely a lot larger now. What I wanted to do, and this is a cool new feature here, is bring up, oh wow, they now have satellite mobile hotspots coming up. That's going to be interesting. But the part that I wanted to show are the live wildfire cameras, which is a really nice way of using the interface to see what's going on. So here's one view from the Chico area looking at the fire. Oh wow, so this was one of the cameras that was overrun last night by the flames. The most recent image is from 19 hours ago because this fire camera tower burned down in the fire. As did, I believe, oh no, this one looks like it survived. You can actually see, let's watch the past 6 hours of this. I'm betting you're going to see this fire sort of, it moved through previously and was moving away. So this camera survived, and now you're getting the live view of the fire as it moves away. Here's a fire closer, a camera closer to the flames. You can see that this is sort of what the fire is doing in real time right now. A little bit washed out camera-wise, but you can kind of see the plume dynamics better here. Very active Pyrocumulus plume. Let's see if this one has a slightly better view. Kind of the same idea that you're getting there. It's slightly hidden. You take a look at this, that's not looking at the fire, so you get the idea. I'm also going to look at that fire in Lake County. Looks like it's called the Acorn Fire. See what it's doing. Also going to look at the camera view here. That's actually looking quite a bit better than it was earlier, and so it actually looks like they're getting a handle on that one. Won't spend too much time. You can see those retardant drops. I'll just show you a couple hours ago. This looked a lot worse. Yeah, initially this looked pretty nasty, but it looks like this may be a good catch as we see over the course of just a couple hours. This thing tries to move really hard upslope, but it looks like some aggressive airdrops really took the heat out of this over the past hour. You can really see this thing looking, so it clearly is still active fire, but not looking nearly as bad as it was earlier. Okay, so, and then again, the fires right now in the Southern Sierra, these would be the Long Fire and the Trout Fire. Alright, so that's mainly what I want to show here. One last thing, I want to show some meteorology. I'm taking a sip of water off camera here, just give me a moment. Speaking for these long monologues can be tricky. Keeping that voice intelligible for this long is sometimes a bit of a struggle. I'm going to zoom in on this a little bit so we see less of the ad. Sorry, Levi. It is a great website. Okay, so this is a geopotential height anomaly map of North America from the European model ensemble. Again, brighter red colors mean more anomalously thick atmosphere in the lower half, which corresponds to anomalously hot lower half of the atmosphere. Bright reds mean rare values of lower atmospheric thickness and heat. Dark blue values, of course, mean the opposite. This is going back in time to Monday. So I'm going to advance forward in time. California is under another ridge, not as extreme as it has been, but it's still notable. But then this is the storm that came through western Canada last night and brought the strong winds to Jasper. It was right about here, so you can see the geostrophic winds, strong southwesterlies, which drove the fire and destroyed much of the town. But then the system moved over right now, as I was showing you, has, I'm going to bring up the screen brush. You can see, again, this is sort of where I was talking about there, this low pressure system here, swinging across, brought the initial southwest winds, fanned the flames, but now bringing some rain, dampening the fires up here. but bringing some breezy conditions to California. This is part of what's driving the southerly winds right now near the in northeastern California. But if I need to hide this again, step forward in time, this system in Western Canada moves east. There's a little bit of a low pressure system over California. This could generate some mountain thunderstorms, hopefully not anywhere else, but this could cause some problems. But generally, this will bring cooler temperatures to Northern California over the weekend, which is good, but also breezier conditions, which is not so good given the big fires that are already at place, but at least we'll get a break from the heat. This western trough lasts through the weekend and then rapidly starts to fade again by Tuesday and replaced by, you guessed it, another significant ridge along most of the west coast. So more major heat in California. This is a week from now. It's looking awfully hot across inland areas once again. Potentially not as extreme as before, but the western flank of this ridge, this is going now into August. Right now, the European model ensemble is suggesting the potential for another more significant heat wave as we go into early August. So, very first week in August, modest additional heat wave following some cooling this weekend, and then potentially a really big heat wave again by August 7th. And also, note how then this is not only centered over California, but that this is once again a west coast wide thing all the way from Mexico up through British Columbia and Alberta once again. So that could be a real issue from a fire perspective. And again, this anomalously warm temperatures they fade a little bit in the ensemble average, but I don't really see any blue anywhere in this portion of the map. And this is as we head toward mid-August. It's looking pretty darn hot. And I also wanted to bring up the projected precipitation anomalies. In coastal California, of course, it's quite normal to have 0 rainfall in July, so that's not really what I'm talking about here. But what I did want to emphasize is what's going on in the monsoon region, where the next week actually looks really dry, so some of those early season gains may quickly fall away. And then also watching what happens across the northern Rockies and western Canada. This little blue region of above average precipitation, slightly above, is sort of from that current system. But as we go forward in time, watch what happens. Things really dry out once again across most of the Four Corners region, and then also up in BC and Alberta. So warmer and drier than average, as I mentioned, for the next couple of weeks up here. Warmer and drier than average across much of the Four Corners. California, neither drier nor wetter than average, although that's really not saying much because usually it doesn't rain this time of year anyway outside of the mountains. So the key story is going to be that we're not done with summer, and summer may have a lot more in store for us in terms of heat and wildfire risk moving forward. Okay, I'm going to take a look at the comments section now. You're going to see me bring my face back up live. All right. So, let's catch my breath here for a minute. Some folks saying that they're up in Northern California near Chico, and so of course can see this fire. Just looking at what the comments are here. There's a question about a Pyrocumulus column collapse. I'll talk about that in a minute. There is a mention that the park fire was arson, and although most fires, the vast majority of wildfires, in fact, are not caused by arson, it does appear that, at least initially, that this one unfortunately was. So this is the rare example of an intentionally human-caused fire that actually has become very severe. Interestingly, historically, arson fires are preferentially ones that tend not to take off for reasons that I won't speculate on for fear of giving people ideas, but suffice it to say that it's not the typical cause of California wildfires. Even though most are human-caused, most of those human-caused fires are accidental, not malicious intent. This one, unfortunately, sounds like it might actually be one of those rare cases where it was. A question about the intensity of the fires being impacted by weather whiplash. So part of the reason why I had predicted a slow start but very active acceleration and then much above average peak to fire season this year in California is because of this notion of whiplash. We recently experienced 2 wet winters, one very wet winter and one modestly wet winter in a row with really favorable growing conditions. We saw a lot of extra growth of grass and brush during that period. There was a low level of fire activity, so except for prescribed burns in some areas, there wasn't really a lot of land being cleared by fires the last couple of years. But then there was a very strong indication that we would see a very hot summer and perhaps a record-breaking hot summer, which has been exactly what happened. You put those 2 things together, extra growth of grass and brush, you have a really lush fine fuel crop, those grasses that dry out quickly, and you combine it with a record rate of aridification of the landscape. So this rapid transition from wet and cool to record hot and record dry, and you get the worst of both worlds. You have more fuel for the fire on the one hand, and then you kiln dry it by having the higher temperatures for a longer period than we've ever seen before in California and a lot of the West. And so yes, it's that 1-2 punch that particularly concerns me, and we just experienced it. And so, I'm increasingly of the opinion that in a lot of different ecosystems, it is precisely this kind of whiplash between wet conditions in some years, but record hot and dry conditions in alternating years, or alternating clusters of years at least, that essentially represents the worst climate for wildfire. Because you can imagine in a climate that just got hotter and drier monotonically, and you never really had these wet events, for example, you would see an initial pulse of extreme wildfire activity, but after a certain point, you would, for lack of a more complex term, just burn it all away pretty quickly. And a lot of it wouldn't grow back, because if you just got perpetually hotter and drier, where's the moisture going to come from for these ecosystems to grow new vegetation? But of course, that's not what we're seeing in California or in most other places. What we're seeing is this increasing alternation between ever greater heat extremes and dry extremes on the one hand, but ever greater wet extremes on the other. And it is during those wet periods where we actually see a tremendous amount of vegetation growth and regrowth, particularly in a place like California that has a really long growing season. The last 2 years were great for plants in California. Hard to be better, in fact. Warmer than average, but not record warm, and very wet with a lot of residual moisture even through the summer in some places in 2022 and 2023. That meant that plants were very happy and they did a lot of growing. And the good news is it meant our forests somewhat recovered from the historically severe droughts of the 2010s, at least for now. But what it also meant is that we just have a lot more biomass on the ground, and that includes some of the recent fire footprints from the 2010s that have filled in with a lot of grass and brush in the meantime. It doesn't mean that the forests regrew in 3 years, but it does mean that these multi-100,000 acre or million acre fire footprints, they're not devoid of vegetation now. They are full of grass and brush that is chest to head height in some cases for fires that burned more than 2 or 3 years ago. And so that is, that is capable of burning at a significant intensity under the extraordinarily hot and dry conditions that we're seeing right now. And they're also liable to burn aggressively under a strong wind event like we might see in the fall. So that alternation, I think, is key. And it's something that's increasingly going to be a signature of California's bad fire years. Some of them may follow wet winters if we have record hot summers. I think we're entering another active cycle for California wildfire. 2021 through 2023 were less extreme. 2021 was still a pretty big year in some areas, I should say, but less so than 2020. But 2022 and 2023 were pretty quiet. There were still some problematic fires, but generally those were quiet years compared to almost any of the years in the previous decade. This year, though, is already not a quiet year for California fire, and I expect that to continue to escalate into the autumn. And I think we're probably entering another active cycle. I would expect right now, although the certainty is lower, I think next year is going to look very active again. So I think until we see another sequence of very wet years, which does not appear, and importantly, a sequence of wet years and not really hot years, This year, again, is what was a fairly wet year, but it is super hot, record hot, and that has made all the difference. Next year, though, the odds are tilting in a direction of both drier than average and much hotter than average, and so following a couple of wet years, I think we're off to the races again, and we're already seeing that evidence right now in terms of the behavior we're seeing on the current fires. So I think we got a bit of a lull, a couple of years where we got lucky. For some reason, some folks pointed to the last couple of years saying, see, it's all reverting to the way it always has been, which of course was never going to be true in a warming climate, but it's pretty obvious that it wasn't true already. So the other piece to this too is that a lot of predictions, including some formal ones from fire agencies and the federal government, called for a below active fire season in California this year, and that was just baffling to me. I've spoken about this a number of times since spring, where I made my own informal prediction that this year would start slowly and quietly, maybe even below average in California, but in July or August would rapidly accelerate to above average conditions and peak with some potentially pretty serious fire activity by autumn, peak season. That's essentially exactly what has happened, and the same is true across a lot of the West, similar to the seasonal progression that I talked about this spring. And I'm genuinely not entirely sure why this was such a poorly predicted fire season, because to me, all of the indicators were screaming that this is exactly how it would evolve, from being an unremarkable season to start, which it largely was, to being a really kind of remarkable season from mid-season onward. And that's looking like essentially this is what's happened from Northern California into Canada. And that was precisely because there are these two different components of fire season that are potentially predictable. One is that in spring, well, we already knew what had happened the past couple of years and this year. So there's the antecedent component to fire season, how much rain fell in the last year, or how good was snowpack the last couple of years, how warm and dry has it been or not. And the good news about that, from a predictability perspective, is by the time you get to spring, you already know the answer. It's kind of cheating, because you don't have to make that prediction. You know how wet it was or wasn't in the 12 months previous because we've observed it. We don't have to predict that part. And we already know that that has some relationship with California fire season and fire season generally in other regions. But then there's also the forward predictive part, which is, okay, well, we know that part looking backward, that has some influence on fire season, but also what's going to happen next. And there were very strong indications that this summer would be exceptionally hot, perhaps record hot. And it has been. And that's the piece that really got me kind of concerned. The spring, which is to say that progression from pretty wet conditions, lots of vegetation growth, to record dryness, meant that we might see a progression that the early season was still mainly responding to that extra wetness. Things were not too bad. There were some great prescribed fire conditions all the way through June in much of California for this reason. But that at some point in the summer that was going to change rapidly, and it did, big time, with a month of record-breaking heat. I would be happy to speak with my colleagues, in some of the predictive services, exactly why we aren't factoring in all of these things to the seasonal prediction, because I feel like this year was a pretty significant but conspicuous miss, and I don't really know why that was. And so be happy to have constructive conversations with folks about that. But suffice it to say, a lot of these seasonal predictions that were updated midsummer have now been greatly updated to include a very active autumn and rest of summer. So I would agree with that, looking forward certainly, but I think that should have been predictable a few months back. So that's likely where we're headed. This is just the start, and it is starting to get kind of crazy out there. We've not seen any mass casualty or structure loss events in California, although as recently as right now, we are seeing fires that are burning structures. But we now have seen this in Canada. We saw it in New Mexico early this season, near Ruidoso. But the real challenge is that the peak is likely yet to come, and in California we may not see a peak until September or October, and depending on when the rains arrive or don't, I have a feeling this year could be a year with significant November fire activity, even in parts of central and northern California, if we don't get an early season rain event. And folks, sometimes it's going to be a weird look when I say significant fire activity into November in northern California, but I don't think I have to remind folks that the Camp Fire, which destroyed the town of Paradise, occurred in November. So that was a huge outlier, but it certainly isn't impossible if we don't get that early season rain following record heat and dryness in the months leading up to it. So that's not a specific prediction. I certainly hope we don't see fires that are that catastrophic, but I do want to raise the level of awareness, because I think that a lot of folks were relying on these seasonal predictions, which just seemed implausibly benign to begin with. So a bit of a tangential answer to a good question there, but I do want to continue to address questions that have come in the meantime. Okay, there's still the column collapse question. I'll come back to that in a moment. Links to websites that I'm using would be helpful. Yeah, so I continue to use an amalgamation of social media. Better for worse, probably for worse. But I am increasingly a fan of the Watch Duty app. I actually don't use it on my phone. I have it installed in case something really blows up locally and I need to know about my own situational awareness personally. But I actually use the web map version of it because I'm constantly on my computer. It's easier for me to use a larger device. And that's what I was sharing with you today. And I'll admit that I was originally a skeptic of a startup sort of drawing together the incredible breadth of information that would be necessary to really encapsulate the real-time evolution of these events, because, I mean, minute by minute, it's hard, and sometimes it's in rural areas. There's no official channels for dissemination of that information still, and this has been true yesterday and today. But I'm actually pretty impressed with what has developed. And the important thing is the core product is freely available. It's not something you have to pay for. I think there's some features that you can pay for, but most of what you would need in an emergency is accessible for free to everybody. So yes, this is a shout out for Watch Duty. And I think that it isn't a perfect solution to everything still, of course, but it's a pretty impressive improvement over what we had before, especially given that, for example, today on Twitter or X, the park fire hashtags were a critical way for searching real-time information on social media because you can filter by time, so get the most recent updates first, was 100% spam. It became unusable. That's the first time I've ever seen that happen for a fire in California. It hasn't been fixed. It's still like that right now. Be careful. A lot of it's not suitable for work type spam. Watch Duty is a place where you can find a lot of that information. And now that there looks like there's the live fire cam reviews embedded directly into the app, that's pretty cool. I think I'm increasingly going to be using it myself for these purposes. There are still some gaps. Last night there was a lot of information about the park fire that was not making it out for whatever reason on Watch Duty and was making it out on social media. But I think the balance overall really is tipping toward Watch Duty specifically as a tool that is really helpful in this space and that continues to improve over time. And that is pretty accessible because it's freely available, the core product, and you can find it via the web on a computer and on your phone. So Ray asks, curious what makes fire behavior exotic? I can't remember if I used that word earlier in the session or if that's a reference to one of my earlier tweets where I definitely used the word. I use that in a pretty narrow context regarding the behavior of the plumes, the smoke, the heat and smoke plumes from the fires. There's a growing recognition that the most extreme wildfire plumes behave essentially, in some cases, like supercell thunderstorms. So severe pyroconvection or severe pyroconvective weather, where the fire actually, it doesn't just start to modify its environment by causing local wind currents, as you'd expect from, you can feel it near like a fireplace or a campfire. If you get close to it, you can feel that sometimes the fire itself will draw in air from elsewhere, converge toward the fire. That's one way that a fire, even a small fire, can influence its environment. But the other way, in a much larger scale, is that large fires like the park fire has been doing today, can start to generate their own mesoscale weather systems that look a lot like severe thunderstorms. And, that's sort of what I would classify as exotic fire-related behavior, where you start to see these supercell-like structures that exhibit a deep rotation of a column that's tens of thousands of feet tall, and can start to produce features as anomalous as lightning. So the fires themselves can start to produce lightning in these cases, where you have a pyrocumulonimbus cloud atop the plume, or things like pyrovortices, tornado strength vortices, effectively fire tornadoes. We've seen these in recent years. That is the kind of behavior that I would consider exotic fire behavior, rather than just, say, extreme fire behavior where you might have rapid rate of spread of flames or very high flame heights or flame lengths. That might be extreme fire behavior. Exotic behavior might be something that would be seemingly out of left field, things that we don't often associate with fires, something that we might more associate with a thunderstorm on the Great Plains during tornado season, and yet these fires are starting to generate. And there is now some evidence, by the way, that we're seeing more of this exotic fire behavior. There is evidence that these large and potentially dangerous pyrocumulonimbus events are increasing in a warming climate as fire intensity increases. That was a bit speculative a couple of years ago, but there is now some peer-reviewed studies that support that anecdote. A lot of us had observed that these appeared to be increasing in frequency and magnitude and occurring in new regions. That now appears to be, to the extent that we can validate it, probably correct. So that's what I mean by exotic fire behavior. Behavior that goes well beyond the fire itself and starts to produce striking or even dangerous phenomena that is not directly related to the flames anymore, but is related to the secondary hazards like the fire-generated thunderstorms or tornadoes or mesoscale weather type features like that. There's a lot of interesting info on Twitter about how this has unfolded with the park fire in particular, although we saw this also with the fire that moved into Jasper last night, and with many other fires, intense fires across the world when they have occurred in recent years. I'm actually going to go share, I'm going to share the live satellite imagery once again, because I think that this is interesting to see. And now, actually, I'm going to share this differently because I don't need to draw anything. I'm going to, bear with me for a moment. Oh, well, actually, maybe I'll show you this first. Well, that's not so interesting right now, anyway, to show this. So, let me... Okay, that's what I wanted to share. So I brought the satellite imagery back up here. I just want to make sure that you're seeing full screen what I'm intending you to see. No, it's not quite full screen. I need to... Sorry, sometimes I'm definitely not a video... There we go. Okay. Now that should be full screen. Oh, I need to shift. That's not Northern California, is it? That's still Canada. Let me just go back down to the park fire. Okay. Yeah, man, that thing is still ripping. It looks like there's yet some new activity on the far southeastern flank. So I'm going to leave that up while I continue to look at the questions here. Oh, now you're just seeing me scroll through the comments. I'm sorry. I need to... Apologies. I need to share the window. It's tricky because I need to... Yeah, this is what I was looking for. if I only share the specific app, then I don't, and you don't end up seeing my red cursor and drawing. But if I share the whole screen, then when I transition back to actually monitoring questions, then you just see me reading the questions list, which I assume is of less interest. Okay, but this is what I was intending to show. Yes, I agree with Alexander that we are. I think that was Alexander who said this. Maybe it was somebody else. Sorry, it just scrolled down on me. That we're primed for some pretty dangerous events in the fall. That's right. I think we are. That is the reality. Mark asks, why is the entire eastern half of the country absolved from forest fires and extended extreme heat? Well, they are not, especially not from extended extreme heat. In fact, most of the eastern seaboard just experienced their warmest month on record also, just like the west, except that it's a much more humid heat, so arguably more miserable for humans, but slightly less bad from a fire risk perspective. But the main answer is that the ecosystems in the east are very different. And the amount of precipitation, I don't think people realize this, but the summer is the wet season, so the warm season is quite wet and stormy much of the time in the eastern half of the U.S. The dividing line is roughly the Rocky Mountains. I'm sitting here in Boulder, and this is essentially the dividing line, almost exactly, east of the Rockies, where precipitation is mainly in the warm season to the east of the line, and mainly in the cool season to the west of the Rockies. And so the eastern seaboard gets a lot more rain than most of the west, multiple times the amount of rain, in fact, in a lot of the western U.S. And so, to put it simply, it's just a lot wetter there, and the vegetation usually doesn't get nearly as dry as. Let me just make sure that the stream is still going, because I'm getting some... oh, yes. So the eastern U.S. is much wetter in general, and they don't have a 3 or 4 month dry season that corresponds with the hottest months of the year, like the western U.S. does, in particular, like California does. So that's part of it. And the real reason, though, is that the fact that it's wetter there more of the time means that the ecosystems have vegetation that itself stays much wetter. So you generally don't get in summer or in fall vegetation that ever anywhere near approaches the level of dryness that we routinely see in California. So in short, the eastern half of the U.S. is a lot wetter, and it can get very hot. Washington, D.C., for example, just saw its hottest stretch on record in the past couple of weeks. But the other piece of this, too, is that the eastern U.S. is not totally immune from wildfire, and that has been a bit of a perceptual issue, in the sense that there is this view that the eastern U.S. doesn't see wildfires, and it does. Think of the destructive wildfire in Gatlinburg, Tennessee, and the Appalachians some years back. I believe it was 2016 or thereabouts. Think about, and this is something that people don't realize, but like the Pine Barrens in New Jersey, for example, so not that far from New York City, it's a potentially catastrophic wildfire risk zone, where some of the beach towns in coastal New Jersey are actually at quite high risk of wildland-urban interface fires. Florida, the Gulf Coast, we see major wildfires in the dense but very moist coastal forests in Florida, and in places that might seem a little bit counterintuitive. Okay, it looks like, by the way, I can see that the satellite feed seems like it crashed, so I'm just going to show my face again. Okay, that's good. It wasn't me. So, it definitely gets hot in the east, but more importantly, the east is much wetter than the west in the U.S., especially during the warm season when fires are most likely to occur. By the way, when there are fires in the east, they often don't occur in summer, but instead occur in winter or spring, because the winter is the dry season in a lot of these regions, and the spring is when vegetation, especially before the grasses and the trees green up, is when the vegetation acts as if it's dead. And so you get dead and down fuel moistures are the most relevant numbers in that context at that time of year. So the dynamics are different. The east is not immune from fires, but there are also intrinsic climatological and ecological reasons why we just don't see fire there as often. It's also worth noting that the most destructive and possibly the largest wildfire in American history still was not a western United States event, but was an upper Midwest event, where the Great Peshtigo Fire and related fires during the same event burned millions of acres of timber and many towns in the 1800s. So you can get huge and destructive fires elsewhere. It's just that the conditions are much more readily aligned for that in the western U.S. far more often. But there will come a day when there's a major wildfire disaster, probably in New Jersey. And there could be another one again in the upper Midwest. So just some food for thought. All right, let's see. Yes, is the live satellite publicly available? It is. It is through the College of DuPage satellite page, although there are also other sources. This is your tax dollars at work. This is a federally funded satellite, and the data is available for free in real time via a number of different platforms. Okay, so the last thing I wanted to cover, and actually there's two more things. One more thing I said I would cover before the fires broke out. I'll just offer some brief points about the recent news headlines about the warmest day ever recorded, just in case there's anybody in the media who wanted a quick comment from me. There have been some data sets that have suggested that of the past century or so that we have these daily records available, that a couple of days this week have been the singularly hottest days on record from a global average temperature perspective, beating out even most of the days from last year, which was the previous time we had similar numbers. I don't want to make too much out of individual days because, quite frankly, we can't measure with a sufficient degree of accuracy global average temperature to distinguish whether one day was necessarily a couple hundredths of a degree hotter than another day within the margin of uncertainty. So were the past several days among the very hottest single days ever recorded in modern human history? Probably yes, on a global average basis. Can we fully distinguish them from similarly hot days last year? I'm not so sure we can. Does that matter? No, I don't think it has any substantive meaning. The point is, what we're starting to see now are individual days that are as hot or hotter than any previous recorded day in modern history. And it's not just happening once or twice. It's not a fluke. In fact, the fact that we're close to where we were last year still is kind of alarming because we don't have El Nino conditions temporarily and naturally warming the Earth by a bit extra this year. So we really can't blame El Nino anymore for any of this. It's not El Nino this time. And we're almost as hot as we were last year at this point. So that's a conversation for another day. What it really is an indicator that the Earth continues to warm at an alarming pace and has shown absolutely no sign of slowing down, as expected, because there's no reason why it would be slowing down. We continue to pump greenhouse gases into the atmosphere, and the total concentration of those heat-trapping gases continues to increase at a rate similar to the highest rate we've ever seen. So there's no reason why we should expect it to be cooler, and it continues to be record warm. But the details are still interesting, and I'll talk about them a bit more later. So that was one thing I wanted to address before closing. And the final one is a question that came up in a couple of places today about pyrocumulus and column collapse. Column collapse is a term that is a little bit controversial in the fire weather meteorological landscape. It's one that's often used by boots on the ground fire folks to describe what can sometimes happen when you get a pyrocumulus, a large pyrocumulus or pyrocumulonimbus, so fire generating thunderstorm. Well, I guess fire generated thunderstorm. I suppose it could also generate a fire that that causes havoc essentially at ground level when it induces strong downdraft winds. So often in a fire, because hot air rises, right? It's more buoyant, it's less dense. The fire itself causes air to rise. That's why you see these large pyrocumulus plumes rising vertically above the fires. But then you can also have downward moving winds sometimes that happen. And it's not always clear whether this is truly a collapse of the convective column or whether this is essentially just a manifestation, as I was talking about earlier, of sufficiently intense wildfires under the right conditions producing effectively their own supercell thunderstorms. Supercell thunderstorms can produce downdrafts. And it's not necessarily because of a collapse of the column. There are other mechanisms that can occur. Sometimes you actually have precipitation that's generated at high levels of the atmosphere, so rain, essentially, but the subcloud layer is so dry that it all evaporates before it reaches the ground. But of course, what happens when water evaporates into air? You can get what's known as evaporational cooling of that air. So essentially you have a fire-generated cloud that's starting to produce some rain, but it's just too dry for that rain to get all the way to the ground. So what happens instead is that rain evaporates. It becomes virga, rain evaporating into the dry air. And as it does so, it cools that air under the fire-generated storm cloud. As that happens, the air actually becomes cooler because of this evaporating precipitation. It becomes less dense than the air around it. And that is what causes the momentum to increase and the air to actually move downward, and sometimes with accumulating force. So you get these microbursts or downbursts within these pyroconvective events because of evaporating precipitation in some cases. That doesn't necessarily mean that the cloud itself collapsed, but it does mean you get some potentially dangerous fire weather behavior with downrushing air and sometimes very strong and erratic wind gusts that can really be problematic in terms of spreading a fire in new directions, jumping over control lines, or threatening fire crews or people trying to evacuate. I tend to think that there are some episodes where a sustained updraft from a fire does suddenly become less sustained. And so normally what would happen when this occurs is you get an updraft, a sort of a bubbly updraft. You see the air, it sort of just goes higher and higher. I'm trying to see where my finger ends up on camera. Maybe this is the top of the pyrocumulus plume atop the fire, and it varies a little bit over time based on the intensity of the fire, but there's got a big puffy cloud on top of the fire. But at some point, either the ambient environmental conditions change, there's a wind shift, or the fire itself temporarily runs into a less fuel-dense area and becomes less hot, and then the height of that plume is going to rapidly decrease. But usually what's going to happen when this occurs is the whole thing, it isn't truly going to collapse. You're going to see the ascendancy of the pyrocumulus plume, and then it's going to fall to a certain point, the equilibrium level, and it's going to kind of oscillate around there, because if you go too far below it, you now have a restoring force where the air wants to go back up. So essentially you have a tall plume, and it collapses, and you kind of have air that sort of bounces like a spring closer to the midpoint above the ground. You don't necessarily just get the whole thing that collapses all the way to the ground. Can that happen in some dramatic instances? Maybe, although I think a lot of what people are saying is probably just more quote-unquote ordinary downdrafts. It doesn't make them any less dangerous, it just means that the mechanism, meteorologically speaking, is probably a bit different. But I do think that there are probably some examples where if a pyrocumulus plume were to be completely cut off from its fuel source in a very rapid fashion, potentially, or something like that, maybe you could potentially have a rapid enough loss of buoyancy of the plume that maybe you could get something that makes it all the way to the surface. Although I think that that would be probably a rare event and is not what most people are actually referring to when they're thinking about these downdrafts from pyrocumulus clouds. Although I wouldn't totally rule out the possibility that in the most extreme scenarios that you could get something like that, some sort of density current that makes it all the way to the ground when you have a sudden loss of updraft. But you really would have to have a specific set of atmospheric stability conditions for that collapse to then make it all the way to the ground, rather than sort of bouncing around the equilibrium level. I've actually had a couple of very intense debates with some atmospheric scientists about this very concept of column collapse, and it does remain a little bit contentious. So maybe a little more in the weeds than most people wanted to know about. I would actually be interested if there's any fire weather or severe convective storms folks out there who wanted to have that conversation, since I'm curious. But either way, these kinds of fires and their pyrocumulonimbus clouds can do so many crazy and, yes, I will call it exotic things, in the sense that they're very separated from the kinds of things you'd normally expect with a, quote, more ordinary fire, that whether or not column collapse is truly something that happens with any regularity, there are plenty of other things that clearly do and cause big problems, and we're seeing some of them right now on the Park Fire. Okay, so I think that's all the time I have today. Thanks again for joining. As I mentioned at the beginning, there are multiple ways to support this channel. The simplest ones are to like this video or others, share them, or subscribe to the channel. And you can also contribute to Weather West via the links that I included at the very beginning of the comments section. So if you scroll up, you will see those. I may have another live session sooner rather than later, depending on how conditions evolve. But with that, I'll close it for the day, and thank you for joining.